The National Electrical Code, or NEC, mandates a separate grounding electrode system, also known as GES, for detached structures like garages, regardless of their proximity to the main house. Even if the garage is only a short distance away, such as 10 feet from the house, the NEC necessitates this independent GES. A key aspect of this requirement is the placement of the ground rod or rods in relation to the subpanel within the detached structure. The code specifies that the ground rod or rods must be located within 25 feet of the subpanel. This proximity is crucial for ensuring effective grounding and electrical safety in the detached garage. The purpose of a grounding electrode system is to provide a low impedance path to earth, which helps to stabilize voltage to earth during normal operation and limit the voltage rise due to fault conditions. This grounding system plays a vital role in protecting both equipment and people from electrical hazards. When a fault occurs, such as a short circuit, the grounding electrode system facilitates the flow of fault current back to the source, allowing overcurrent protection devices like circuit breakers or fuses to quickly trip and energize the circuit. Without a proper grounding system, fault currents may not be effectively cleared, leading to potential risks of electric shock, fire, and equipment damage. The requirement for a separate GES in a detached garage is driven by several factors. Firstly, it helps to minimize the impact of voltage differences between the main house and the detached structure. Because the earth is not a perfect conductor, there can be voltage gradients across different points on the ground. A separate GES helps to equalize the potential between the garage and the surrounding earth, reducing the risk of voltage differences that could cause electric shock. Secondly, a separate GES provides a dedicated grounding path for the detached structure, ensuring that fault currents are properly routed and cleared. Relying solely on the grounding system of the main house might not be sufficient, especially if the distance between the house and garage is significant or if the grounding impedance of the main house is high. Thirdly, the NEC requirement for a separate GES aligns with the principle of providing multiple paths to ground. By having both the main house and the detached garage grounded independently, the overall reliability and effectiveness of the grounding system are enhanced. In situations where the main house's grounding system is compromised, the garage separate GES can still provide a degree of protection. Now let's consider some of the specific requirements and considerations for installing a grounding electrode system in a detached garage. Firstly, the grounding electrode system must meet the requirements outlined in Article 250 of the NEC, which covers grounding and bonding. This article provides detailed specifications for the types of grounding electrodes that are permitted, the methods for installing them, and the requirements for bonding the grounding electrodes to the electrical system. Secondly, the most common type of grounding electrode used for detached garages is a ground rod. The NEC typically requires at least one ground rod to be installed, and in some cases, 2 ground rods may be required, depending on the soil resistivity. The ground rod must be at least 8 feet long and must be driven into the earth until at least 8 feet of its length is in contact with the soil. Thirdly, the ground rod must be made of a suitable material, such as copper or copper-clad steel, and must be of the correct diameter. The NEC specifies the minimum diameter requirements for ground rods based on the material used. Fourthly, the ground rod must be connected to the grounding electrode conductor, which is a wire that runs from the ground rod to the grounding bus in the subpanel. The grounding electrode conductor must be sized according to the requirements in the NEC, based on the size of the service entrance conductors or the feeder conductors supplying the subpanel. Fifthly, the connection between the ground rod and the grounding electrode conductor must be made using a listed connector that is suitable for direct burial. This connector must be designed to withstand the corrosive effects of the soil and must provide a reliable electrical connection. Sixthly, in addition to the ground rod, other types of grounding electrodes may be used, such as a ground ring, a concrete encased electrode, or a metal underground water pipe. If a ground ring is used, it must be encircling the building or structure and must be buried at a depth of at least 2.5 feet below the surface. If a concrete encased electrode is used, it must be encased in at least 2 inches of concrete and must be located within the bottom of a concrete foundation or footing that is in direct contact with the earth. Seventhly, if a metal underground water pipe is used as a grounding electrode, it must be in direct contact with the earth for at least 10 feet. The water pipe must be electrically continuous and must be bonded to the electrical system using a bonding jumper. Eighthly, it is important to note that the NEC prohibits using certain types of metal objects as grounding electrodes, such as metal fences, metal siding, or metal gas piping. These objects are not suitable for grounding because they may not provide a reliable electrical connection and may pose a safety hazard. Ninthly, in situations where it is difficult to achieve a low impedance ground, such as in areas with rocky soil or high water tables, it may be necessary to use multiple ground rods or to install a chemical ground rod. A chemical ground rod is a specially designed ground rod that contains chemicals that help to reduce the soil resistivity and improve the grounding effectiveness. And tenthly, it is also important to ensure that all metal parts of the electrical system in the detached garage are properly bonded together. This includes bonding the metal enclosures of electrical equipment, metal conduit, metal water pipes, and any other metal objects that are likely to become energized. Bonding these metal parts together helps to create a low impedance path for fault currents, which improves the operation of overcurrent protection devices and reduces the risk of electric shock. The bonding connections must be made using bonding dampers that are sized according to the requirements in the NEC. In summary, the NEC requires a separate grounding electrode system for detached garages, regardless of their proximity to the main house. This requirement is driven by the need to ensure electrical safety, minimize voltage differences, and provide a dedicated grounding path for the detached structure. The grounding electrode system must meet the requirements outlined in Article 250 of the NEC and must be installed in accordance with the manufacturer's instructions. It is important to consult with a qualified electrician to ensure that the grounding electrode system is properly designed and installed.